The national distribution of fatal work injuries in a country is shown in the table to the right under national percent. You believe that the distribution of fatal work injuries is different in the western part of the country and randomly select 6,231 fatal work injuries occurring in that region. At alpha equals 0.05, can you conclude that the distribution of fatal work injuries in the West is different from the national distribution? Complete parts A through D below. First, we need to state the null hypothesis and the alternate hypothesis. The null hypothesis, H naught or H sub 0, will come directly from this particular problem, and it's going to be based upon this column right here, national percent. So here's your null hypothesis. So H sub 0, the distribution of fatal work injuries in the West is 43% transportation, 19% equipment, 14% assaults, 13% falls, 9% harmful fumes, and 2% fires. And then we need to state the alternate hypothesis, which is the fact that we think that this is not accurate and that the frequency in the West will differ from the null hypothesis. And so the null hypothesis, H sub A, is the distribution of fatal work injuries in the West differs from the expected distribution. Which one of these hypotheses is the claim? Well, H sub A would be the claim because that is what is taken directly out of this. We say that in this problem, the statement, you believe that the distribution of fatal work injuries is different in the western part of the country. So that means that H sub A is going to be our claim. So H sub A is the claim. Okay, the next part of this is to determine what the critical value is, which would be chi-squared sub naught, or sub 0, I should say. And so we need to use the table in order to do that. And that table is going to be our chi-squared distribution table. And I've copied in a portion of the distribution table. In order to do this, we need to determine the number of degrees of freedom. So degrees of freedom is going to be equal to the number of categories that we have in the table above, and we're going to subtract 1 from that. So there are 6 categories. Therefore, the degrees of freedom for this particular problem will be equal to 5. And significance level of alpha is equal to 0.05, which is this column right here, and our degrees of with a degree of freedom of 5, our chi-squared value will be 11.071. So degrees of freedom is 5, alpha is equal to 0.05, and that is going to be the value that we will be comparing to. Now we need to determine what our rejection region is going to be, so we're going to take and compare our calculated chi-square, and that will be greater than the critical value chi-squared sub 0 or chi-squared naught, and we'll be using this particular diagram. Our rejection region will be in the right tail. So if we calculate a chi-square that's greater than the critical value, then we will reject our claim, or the null, depending on which one we're looking at. So we're going to calculate chi-squared, and what we're going to do is use technology for this. And you'll see that in the given problem, and the table that we're looking at, there is this little icon right here, and if you left click that icon, you will get this pop-up menu, and you want to go ahead and highlight and then left click on Open in StatCrunch. In doing so, you get the following window that opens up. Notice that the first column is going to be the labels, the second column will be national percent, and the third column is the Western frequency. In order to do the actual comparison, the national percent is going to need to be in terms of numbers, not percentages. So we need to convert that. Now, in order to do that, we need to remember that our n is 6,231. So let's go ahead and write that down. N is equal to 6,231. So bringing back the StatCrunch table, we're going to go ahead and do some calculations to convert this column national percent into actual data that we can use. So we'll left click the data button in StatCrunch, and then we will scroll down and highlight compute, and then we will left click expression. We're going to create a new column, so we're going to change the label here. So we'll just type in this field down here under column label, and we're just going to put down national data. And that is now going to be converted from a national percent into data values. So we'll left click build right here because we need to create the expression. First off, we're going to open parentheses. Notice that there are two parentheses here, open and closed. We're going to type in our expression, and it will fall between the parentheses. In order to go ahead and convert the national percent from a percent to a decimal, we will double click national percent, and you'll notice that it fills in this field here. We need to divide that by 100 in order to convert that into a decimal. Then you're going to left click just to the right of the parentheses so that your field moves. We're then going to multiply that by n, which is 6,231. And that is what we want to happen in our data set. So we'll left click OK. You'll notice that the expression is now filled in this form, and left click compute, and we now have a new column. This represents the national data, and we are going to compare that to this Western frequency. In order to do that, we will then left click stat, scroll down to goodness of fit, and then left click chi-square test. The observed, that is going to be the Western frequency that we are looking at for data. So we left click Western frequency. Our expected is going to be the national data column, so we will left click this and we will highlight national data. You don't need to worry about the rest of this stuff. We'll just left click compute, and in this particular problem you'll see this little table. And that's what we're interested in. And you'll see that our chi-squared value is 31.69997. Generally speaking, you're going to round that to 3 decimal places. So chi-squared calculated, rounded to 3 decimal places, will be 31.700. And we're going to use that to determine whether or not we will reject or fail to reject the null hypothesis. Okay, we know that our chi-square, our test statistic from the table, is going to be 11.071. Now, how does that compare to our calculated statistic of 31.700? Well, that's going to be well within the rejection region. So, we will, for this particular problem, we will reject the null hypothesis. At the 5% significance level, there is enough evidence to conclude that the Western distribution of fatal work injuries differs from the national distribution.